Luka Ozimek, a rookie presenter. He's here to enhance our knowledge.
Hello. Everyone can hear me, right? Yeah, I think so. All right. How do we start off? This is how we start off. It's weird to finally be the one up here that no one's listening to. But thank you, Anthony. Anthony's listening, guys. This is tooling around with an ESP32-S3. I'll ask everyone to bear with me because this is my first time presenting and first time speaking in front of people for like a long time. I think it was like last semester in, what was it? Public speaking, something like that. Yeah, it's been a while. And I definitely managed my time poorly getting this done. I did this all in like basically 2 days. Yeah, but next time I would have taken more time. So we're gonna dive right in, but that's after everyone's favorite slide, the Who Am I slide. So I am Lukash, that's how you pronounce it, Lukash Ozimek. I'm a second-year cybersecurity major now, after previously swapping from my software engineering. I thought that CSEC was a lot cooler. The topics were a lot better. So I'm from Connecticut, where the best pizza is made in the world, by the way. So, yep, everyone who's, all right, you can leave. No, I'm kidding. Specifically from Glastonbury, Connecticut, which is like 10 minutes out of Hartford, if anyone knows where that is. I'm a Minesweeper enthusiast. I play that very often, not as much because I've been busy. I love sports, New York sports fan. What's your question, Will?
Jalen Brunson or LeBron James?
The question was Jalen Brunson or LeBron James. I'm going to have to go with both for now. But give me time to think about that one because it's really hard. So where was I? Only the right teams, though. The Knicks, Rangers, Mets, and Jets. So if you don't like those teams, that's kind of tough for you. Besides that, I love listening to music. I've been listening to lots of Tool lately. I play the bass from time to time. I don't have as much time to do that now, but it's still fun to whirl around with. And one last thing, this will be the Jets record next year for all those who care. You can see it says 17-0. They go all the way to the Super Bowl and win. And if you look into the left there, you'll see the Bills are 0-17 also. So I don't make the rules, that's just how it is. All right, so here we actually are. So what is an ESP32? That's what I was asking myself when I got this for Christmas. It's this neat little thing that I got right here. You can't really see it. It's really, really small. I can pass it around or give it to people afterwards if you want to mess around with it. But specifically the one I have right here is an ESP32-S3. It's got a 1.28-inch LCD touchscreen. It's basically just a little microcontroller that's developed by Espressive Systems. That is, it's like strangely powerful for how small it is. You can get it off of like Waveshare or Amazon. It goes for like 20 to 30 bucks, I think. And there's a bunch of other models too. Getting more into the weeds of the hardware, which I might skim over because it doesn't really matter. It's got an X-Tensa 32-bit LX7 dual-core processor. Supports 2.4 gigahertz Wi-Fi and Bluetooth 5 low energy. It's got some SRAM. It's got ROM, flash memory, 16 megabytes. The touchscreen, which I mentioned before, and it even has a 3-axis accelerometer and 3-axis gyroscope for detecting motion gesture. So if like you spin it around like your phone will know it's upside down and like adjust itself accordingly. This can do that same thing. And as I mentioned before, this is an S3 version compared to like an S2 or an S1. It's basically just a beefier version of the ESP32. So this thing sounds cool in theory, and the schematics, like some big words that seem cool, but like what does that mean? What can it do? It can do a lot of mundane tasks, but also some really cool security-related things too, and even some machine learning, which I'm going to get into later. But it's mainly used in IoT or Internet of Things applications like smart devices, embedded systems, because it's got a pretty good processor on it, and it's got wireless connectivity too. Mentioned before, it's got Wi-Fi and Bluetooth connectivity straight out of the box, allowing you to connect this device to things like that you might have around your room, that thing that you might control with your phone, basically. If you can turn your lights on and off with your phone, you could probably do the same thing with this. Well, I know you can do the same thing with this. I even heard it can like measure things like temperature and air quality, probably, which I did not test myself, but maybe in the future. And lastly, without revealing too much right now, it can recognize handwritten letters and process other commands that I might encounter too. But I'm only speaking on that functionality lightly right now because I'm saving that part for later. And just a little more exposition before we finally get into it. Sorry, it takes a while, but for my research, I used 3 main things and a 4th, which I tried to use, but I had some trouble. So the demonstration for that will be saved for a rainy day. The 4 things are MicroPython, the Arduino IDE, Thonny, and TensorFlow. It felt kind of weird throwing in MicroPython here as something I used, but since it's a programming language, but I still needed to use it to get this stuff done, so I thought, why not throw it in there? And so we're starting off with MicroPython right here. For those who don't know, it's just a subset of the Python 3 library. It's just Python 3 but dumbed down so that it can run and fit on this small microcontroller right here. It's still got a bunch of things like an interactive prompt, precision integers, exception handling, and more. It can't the ESP32 can't contain the full Python library because that's just too much information for it. I didn't have any issues with MicroPython because it ran the same as Python, but I did have trouble getting the firmware onto the device at first. What you need to do to download the firmware is simply it should be simple. You plug the device into your computer, find the correct MicroPython firmware, the correct version, and then flash the firmware. But if you speed through some of the instructions like someone may or may not have done, you will wind up in a boot loop where you can't run any other commands, and you can't stop the command from running though because the process hasn't finished. So you need to wait for the boot loop to finish, but then once the boot loop doesn't actually finish, it boots again. It's really confusing and really annoying. I don't know how I fixed it and how I got it to stop printing a giant wall of text, but I ended up making it work. That's actually what it would look like in your serial monitor terminal. Sorry. This isn't my boot loop screenshot. This is more like a reset loop because I didn't have the foresight to take a picture of that. I was raging, and I just wanted it to start acting normal. Arduino IDE, it takes the place of VS Code. It's basically your traditional IDE, but it's open source software. And the additional functionality is that you can upload this directly to boards and get it to start running immediately. That's why you would use something like VS Code or that's why you would use this over something like VS Code or, I don't know, Eclipse, if anyone uses Eclipse. Raise your hand if you use anything other than VS Code. All right. Everyone, let's laugh at Connor. Huh? All right. Everyone laugh at Connor Fox. Arduino was fairly easy to use. It has things like autocomplete, a live debugger, and other various libraries. And here's a cool diagram of the Arduino interface looks like. I don't know if you guys see what I see, but it is in French. So, but luckily I speak French. Your drop-down menus, compile button, upload button, a new file, open a file, register device, the port it's connected to, the serial monitor, text editor, and blah, 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 blah. There's your French lesson for today. Here's where I'm going to throw in that the ESP32 can actually run C++, but I didn't use C++ at all because nothing that I wanted to do was like performance intensive where it needed to be like streamlined. And Python compiles slowly compared to C++, but I didn't need to compile it quickly. So, and then Thonny, I don't even need to explain this. It's just another IDE, even more dumbed down. It doesn't have like the special libraries, and I'm pretty sure it's only used for Python. I used it like maybe one time, but I'll just throw that in. Just use Arduino instead. It's cooler. Okay, now we get into an actual like thing that I did. So this is aliens.py. I wanted to try to get something to pop up on the LCD screen at least once, right? Because it's got an LCD screen. Why not use it? And so I was very delighted to find that the WaveShare page for this device, the WaveShare wiki, had a bunch of demos that you could just download and start running right away. And so I installed all of those, and the one I liked the most was aliens.py. It's pretty similar to the CTF we just had, which was alien invasion themed, so I thought, why not include that? What alien.py does is just randomly displays an alien JPEG and rotates it randomly, displays it. On the board, it can be kind of a pain to resize images, which I'll talk about later. And all you got to do to run this is click the upload button, and it'll start running immediately. Same with every other file or script that I uploaded to this device later. Okay, but how can this be used offensively? Because aliens.py is cool, but it's not really that cool. You know what I mean? More fittingly, how can the ESP32 be used in relation to security? So this is where we get into the fun part. So number one, the ESP32 can actually sniff packets, which I had no idea at first. I told Dan this, and he was like, yeah, you didn't know that? It's like, are you serious? But whatever. It's pretty simple, but it's still pretty cool. This is possible because the ESP32 has a promiscuous mode, allowing it to sniff packets without having to be connected to an actual network. It's very similar to, well, it's exactly like Wireshark, if you used Wireshark before, which you probably have. In the code that I uploaded, I wrote how to format the captured data. And in this instance, I segmented the data by the source MAC. The source MAC address of the data that was sniffed, the RSSI, or received signal strength indicator, which basically just shows how strong the signal is and how close the device that you're reading data from is to the ESP32. Someone smarter than me can figure out how to take this one step further, and it is possible, but I wasn't able to do it. But you can directly capture the packets through the ESP32 and then send it into Wireshark and have all those packets up there, show up into Wireshark and then analyze them further. You can do this in like a couple ways. One of the ways is using like virtual COM or COM0COM to try to pipe the serial data into Wireshark. But another way is also capturing the data on the ESP32 and then using UDP to reroute it back to, using UDP on a specific port to route it back to like your computer, where your computer is capturing all the data, sorry. It's kind of interesting, but here's the actual raw data in hexadecimal format to show that I didn't just make all those numbers up right there. I don't know what any of that means. I can't read that right now, but it's something. It's got 162 bytes right there also, and the packet length is 153 for the other one. Those are just two little snippets that I saw and picked out. And so the next cool thing is a BLE scanner. The ESP32 can detect BLE emissions, which is Bluetooth Low Energy, for those who don't know. Bluetooth Low Energy is just a different version of Bluetooth. It's designed for low power applications, while normal Bluetooth, like Bluetooth 5 or 4.2, prioritizes high-speed data transfer. So what that means is that an ESP32 should be able to find little devices that use BLE, things like fitness trackers, smart devices, and maybe even AirPods, which I'll get into later. So I got the code written up. I uploaded it to Arduino, and uploaded it to the board, and with the board, I started scanning, basically, and voila. I asked the board to gather a device name, if applicable, because some device names aren't out in the public to be scanned. I asked for the MAC address or the Bluetooth identifier for the device, then the RSSI for the signal strength also. It takes like 5 seconds each time it scans to look for devices, and it printed all that info in the serial monitor. If anyone wants a demo, I can probably spin this up in a couple seconds, and we can check the devices in here later if you want to. And so more on that, I changed the output to just put a greater emphasis on the name of the device, if it was available, and I found the UUID too. The UUID stands for Universally Unique Identifier, which is a 128-bit label that uniquely identifies stuff in computer systems. And so as you can see here, there are 2 devices with names that are available: DREO HM03W2C and TI or TY. And lastly, there's another unnamed device, but it still has a UUID that I can put into a UUID decoder. And that's cool and all, but I still have no idea what any of this is, right? I can't know what a device is by just the Mac alone. But if you take in routing and switching, then you might recognize that the first 24 bits of a MAC address are an OUI, or Organizational Unique Identifier. So I use this little tool called the Wireshark OUI lookup tool, which basically you just plug in the first, as I said, 24 bits, and it should tell you what company produced that machine. And so I plugged in the DREO device into there, and I found it was from a company called Part 2 Research. I don't know if anyone's ever heard that before. I hadn't heard of it before. So I still didn't really know what this thing was. But I dove into it deeper, still looking around, and I found a Reddit thread that saying it was their DREO oscillating fan. And I was like, an oscillating fan? Where the hell would that be? And then, you're never going to believe it. That's my fan in my room. It was right behind me, 5 feet. So, the other two, the UUID 5205C11, is something from Blue Giga, which is a Finnish Bluetooth module company. I couldn't really figure that out. I didn't know what that aligned with. And the other thing, TY, is from Tuya Smart Incorporated, which is a Chinese company that offers smart devices. I don't know if those were different devices or they were also part of the fan somehow, because my fan uses Bluetooth. It's got a remote controller, so that was cool. But I knew there was still one more device in my room that I would be able to find. I was searching around, like scanning for a while, and I had finally found this thing called KS03-11003A, as you can see up there. And I was pretty sure what this would turn out to be. It was, boom, my LED lights in my room that I had strung up. Even though the OUI wasn't registered, I was pretty confident that the KS03 were my lights for 2 reasons. One, when I moved the ESP32 closer to the lights, the RSSI number went up from -80 or -90 to -60, which again, the greater an RSSI number is the greater the signal strength. So if I move it closer to the thing, the signal strength gets greater. I should be getting closer to the device I think I'm looking at, right? And finally, like the nail in the coffin is when I looked in the instruction manual for my actual lights, I saw that to pair your phone to my lights, I had to look for a Bluetooth device beginning with KS03. So there you have it. After that, though, I found most of what I could find. I was kind of done scanning random BLE emitting stuff. It was getting a little boring. I tried to look for my JBL speaker and other devices, but I don't think they use BLE. I think they use actual Bluetooth, most likely, so that's why I probably couldn't find them. I tried to plug in other UUIDs into a decoder, but it would always result in me getting the OUI for HP, for an HP device, but I don't have an HP computer and no one in the house has any HP devices, so I don't really know why that was popping up. And also, like, I would plug in multiple different UUIDs and they would still result in an HP OUI, which shouldn't really happen. There can be collisions with UUIDs, but it doesn't really happen that often. And I doubt I would find 3 devices at one time that are all HP. So maybe something has an HP NIC in it. I don't really know. I have to look into that further probably. And so lastly for this one, was I able to find my AirPods? Maybe. I turned them on and I put the ESP right next to my ear with the plugged in AirPods, and I found the closest RSSI that I'd ever gotten at negative 17, yeah, negative 17. So maybe this is them. I have no UUID though, and I don't think AirPods have MAC addresses. I'm pretty sure they have Bluetooth identifiers. Oh, I have written down here. Is James Southcott here? Does he know? Yeah, all right, whatever. I don't know either. So, but if it doesn't have a standard MAC address, I'm not going to be able to find an OUI for Apple, even though I looked for it a lot, but that's not going to happen. So maybe these are my AirPods. No, why you thought? Yeah, okay. James says no MAC address. So maybe that's them. I don't know. I'll have to look into it further. But a negative 17 RSSI, I'm pretty convinced. So, okay, now we're entering territory that is way outside of my current scope. But I couldn't pass up showcasing this right now. I didn't test this myself because I kind of ran out of time. But I found something really cool, I think. I was trying to make a deauthentication detector with an ESP32, which I wasn't really successful with at first. I'll have to try again. But that's when I came across this thing, and it's basically just a set of files that turn the ESP32 into a Wi-Fi penetration tool. You can upload the code and spin this thing up, and it'll actually create its own access point that you can connect to on your computer through default credentials. And then if you navigate to your browser while you're on this, this network and go to a specific IP, you'll be met with that screen basically right up there. If you can see there, they have the, so it's scanning for machines that are up right now. So it'll have their SSID, their BSSID, and RSSI. You can choose any one of those to basically perform an attack on. You choose your own attack type, the attack method, and for how long you want to do that attack too. And you can refresh the target list to see new devices that pop up too. But diving more into what attack types and methods there are, there's a passive attack, an active attack, PMKID, and even denial of service too. And those can all be done in different methods like the deauth rogue AP or rogue access point or passive, deauth broadcast, which is active, and capture only. But so to put it more bluntly, the ESP32 can be turned into a tool that has PMKID capture, WAP, WAP2 handshake capture and parsing, deauthentication attacks using various methods, denial of service attacks, format and captured traffic into PCAP format, parsing captured handshakes into HCCAPX files, files ready to be cracked by Hashcat, and passive handshake sniffing too. I was conflicted about including this part because I didn't invent this and I didn't actually run this at all yet, but I thought it was too cool to not mention at all, and it still, I guess, counts as research because this is like red teaming and hardware, and I found it through research. So that wraps that part up. And so here is what I originally set out to do. The ESP32 doesn't technically do machine learning itself. It's just the model can run on the ESP32. It can be turned into a smart device with train recognition software on board of the ESP32. And so what did I want to do with this? I wanted to train a machine learning model on the ESP32 to recognize certain letters drawn on it on the LCD touchscreen that I mentioned before, and basically print out on the screen again the letter that was drawn from it. I wanted to build off of that and basically have the machine learning software or the model be able to recognize full words and print out that word. The word would have been cat because it's only 3 letters, and each letter is written pretty distinctly from each other, so that should be easy to recognize. And then the last level is that I wanted to write the word cat on it and the corresponding image to that word pop up. So if I wrote cat, then an image of a cat would pop up. That's what I wanted to do. It's shelved for now. I didn't have time to figure that out. I was having lots of firmware issues, and neural networks are like really tough. But I'm still going to explain how that works and basically what I'm going to do in the future. So in short, we need to draw letters on the screen, convert the finger strokes into a grid of pixels, feed it to a neural network, and have that neural network spit out the correct letters back out to me. But there are, broken down more, 3 key steps: collecting samples, training the model, and then running the model. So before I get into that, Anthony mentioned TensorFlow. I'm going to talk about that a little more, little quickly. It's an open source, versatile platform. It's developed by Google, primarily used for building machine learning models, especially deep learning models. It can perform various machine learning tasks, including image recognition, which is, sorry. Well, what? Someone outside? I was like, oh, did I put something up on screen by accident? While often used with Python, TensorFlow also supports other languages like JavaScript, C++, and Java itself. And the primary reason why I was going to use TensorFlow is because it's great for image recognition, object detection, and also text generation. And so moving on to part 1 is collecting samples. This part is simple enough. What we're going to do is we're going to run 2 scripts at the same time to make collection easier on the computer. We'll have one script running on the ESP32 that actually tracks where the screen was touched, sort of like a grid with coordinates corresponding to pixels where you touch the screen. While the other script running on the computer is the one actually prompting you for specific letters to write. So if I wanted to write B, the computer would tell me to write B 10 times to collect 10 samples, to then later store that data and process it into the neural network. On to training the model. This is going to be a high-level overview because I still don't understand a lot of this. It's still like really advanced. And this is where we're training the actual model. ChatGPT is my best friend and will be my best friend for when I actually end up doing this. So what we're going to need to do is we're going to need to make another Python script to process our touch data and then convert it into a format which is actually suitable for training. So the ESP32 touchscreen has a resolution of 240 by 240, but to create a small model, we actually need to scale it down to a binary grid of 32 by 32, with 1 meaning touched and 0 not meaning touched, or meaning not touched, sorry. But once we get that grid set up, we're going to upload those recorded samples and then prepare the data set for training. I've got a bunch of info written down here about convolutional neural networks with 2 convolutional layers. That's flattened out into a bunch of nodes, but I don't understand any of that, so I'm not going to mention it. I'm just going to keep moving on. But after all that mumbo jumbo, once we have our trained model, we just need to convert it into a TensorFlow Lite format because TensorFlow Lite is designed to run on embedded systems, just like our ESP32. Also, this conversion process just optimizes the model that was made too, but it still maintains accuracy. And so actually running the model. To run this model, we're just going to build off of the WaveShare demo files that I previously mentioned because they already have the LCD and touch screen drivers that are important to make things appear on screen and to recognize where the screen is pressed. To do that first, or to collect data, we actually need to allocate some memory. We need to continuously capture user input. We need to scale the image to 32 by 32 so that it can be convert it into the binary grid that I mentioned before. And then finally, we need to feed it into the model for for inference. But after that long process, the final result should finally be displayed on your screen. I don't have a demo right now, as I mentioned before, but if you imagine just you write B on the screen, it'll say processing, and in 3 seconds, it'll print out in text the letter B, which is pretty cool. It's not always foolproof, though. If you write a letter weird enough, it will not recognize it. And sometimes some letters get mixed up. So if you write, I don't know, a C and an O, like it might register an O as a C and a C as an O sometimes. That's where continuously training the model and feeding it more data. So instead of 10 samples, maybe like 50 or something like that. That's where you can refine your neural network and make it recognize things with greater accuracy. This is just the explanation of what I'm going to do, and this is definitely going to be another presentation at some point. I just don't have the time for it, but that wraps up neural networks for today. And I'm getting pretty tired up here, so we're nearing the end of the presentation. And so, as I'm wrapping things up, however long it's been, I don't know, I forgot to start my timer. I hope that I actually had enough cool stuff to present instead of just like, it feels like it's all just been exposition, basically, but I'm gonna go over in the future, what I plan to do with this thing, which I've kind of already done like throughout this whole presentation, but I'm definitely gonna try to capture packets again and have them directly show up in Wireshark. Above all else, I wanna get the machine learning thing working, because that's what I originally planned on doing. I just need more time for that. But on the more fun side of things, I was thinking that, maybe somehow this ESP32 could be changed or turned into an ISTS challenge or a CTF challenge somehow for next year. I've got an idea. I don't know how good enough of an idea it is. It might be too easy, but when the letter recognition is uploaded to this thing, I can upload certain letters, like throw a Caesar cipher onto it, and basically make it where you have to write the letters that the ESP32 recognizes. So let's just say 5 letters, like A, B, C, D. Those are the letters it recognizes. You have to find that and then figure out what the Caesar cipher that was applied to it, decrypt that, and then basically rearrange the letters into your flag. That might need a hint, it might not, it might be too easy, I don't know. If people are interested in that, then I'll definitely look into it. I think that could be interesting, though. And so here are the challenges I faced in reflections. Basically, like, all of it was challenging. But this process was also a lot of fun. This is my first presentation. I learned a lot from doing this. I learned that I need more time than I think I need. I finished this like 10 minutes before I started presenting, but I'm clutch like LeBron, so you know what I mean. Some other things got in the way. I had a linear algebra test that I really had to study for, so that took up a lot of time. And I really wanted to present before the semester ended, so I just thought I'd lock in a presentation time and then work from there, which is it might be a little backwards, but I mean, I think it turned out pretty all right. So it was a pain having to troubleshoot and having to read so many directions that I didn't want to read because I just wanted to do things right out of the gate. But again, that caused actually a lot more issues for me that I mentioned, like the boot loop that I was stuck into for like 20 minutes was really annoying. And anyone in here is on the fence about presenting, I'd say you definitely should do it. It's been pretty fulfilling. Yeah, you should definitely present. It's really fulfilling. Like I'm here at the end and I'm like, wow, thank God this is done. But this was a really fun process. If anyone has any advice on how I can work on things and present better for next time or whatever, come up to me afterwards or DM me or whatever with tips and pointers. I'm glad to take any criticism. And so thank you, everyone. Any questions? Lucas?
It looked like you learned a lot of languages while you were doing this project, like MicroPython. I wanted to ask, how easy was it to pick up those languages?
MicroPython is basically just Python. There's like I don't know the full Python library, so there was a lot of things like that I hadn't seen before. It was like to start running on a port or something like that, or to start a frequency. I can't remember. It was a serial.begin, which I had never seen before. And as opposed to, so what I first tried to do was I tried to do, okay, I should actually repeat the question. So Lucas said that he asked, how difficult was it, or what was it like trying to learn a new language, basically? But my response is really, really similar, so it actually wasn't that difficult. Where was I? Sorry. Yeah, so what I first tried to do is I tried to make a hello world function that everyone tries to do, print hello world. So I did, like normal Python, I thought, just print hello world, right? But then I got a big error saying, like, no, you can't do that. Print is not recognized. So it was just a little fix. You just had to do serial.print and then print the word, and it did. It printed to terminal like normal, but just like little things that you have to like learning a new language, just little things, but it's like the same structure, the same framework. So a little challenging, not that challenging, but thank you. And Will?
Yeah, do you know if MicroPython, is that like, I know it's more lightweight than normal Python. Is it, do you know if it's like faster at all in runtime?
I don't know that at all, but I'd have to assume it's the same. It's like same architecture, just there's less libraries and less information. But I think compilation is the same process as it is for normal Python, so I'd have to say it's like the same speed, is what I would assume. I'll look into that, though. Stella. How can this be used offensively? That's actually something I covered earlier. Kind of. Where is it? There we go. But, yeah. So, I actually thought about this before. Here, 1 second, James. When all you need to get this thing to start running is a power source. It'll start running automatically if you have a power source plugged into it. So if I plug in like a little battery to this and throw it on someone or leave it in the corner of a room, it's so small you probably would not be able to recognize it. And I could just collect data that whole time and then later go and find it, upload all that data, and steal all your information, basically. So if red team comes in here, pops this into the blue team's room somehow, it doesn't really make any sense because why would you, I don't know, you would already have their network traffic probably. But if you wanted to use it for that, that's probably how you could use it offensively. And as I mentioned before, it also like it can be turned into a full-on penetration tool where you can send deauthentication attacks and denial of service attacks on things too. So if I wanted to shut my MacBook offline, I would find my MacBook's MAC address and select for time, like, I don't know, a minute, and then click the button to basically take this offline for 60 seconds. So I didn't mention what the question was either. The question was, how can this be used offensively? So, but James. I definitely am going to try it on my roommates. I can take down a whole network, so I can take down everyone that's connected to Lodge 22A if I wanted to. So as soon as I get that uploaded, I will inform you about that. Oh, is it? Oh, okay. The Wiggles lead? I don't know. I'm gonna hope that he's too busy to retaliate. So, anything else?
All right, good stuff.
Thank you.